Hi all, welcome to my channel. In this video, we're going to discuss about one of the most important concepts in Java, concurrency, features and also completable features and also callables. So without any further ado, let's start. If you're first time viewing this video, I have basically uploaded all the videos related to Java concurrency, and also we have talked about some of the core internals of concurrent hash map, also copy on array list, and we have implemented our own those data structures also. So everything in detail I have uploaded already in YouTube and also my GitHub link. Please go and watch. I put the link in description. Now let's talk about this video about features, callables and completable features. So what exactly these features, right? So this features interface is basically designed for an asynchronous programming, like so basically it will hold the data which comes in future. So whenever you submit any task, right, whenever you basically submit a task, we'll discuss about how to basically submit a task and accept a task in next video through executive service. But let's assume you can basically submit a task. That task will basically get some information in future. That future when it will basically gets, right, that future data can be held via this future interface. The feature provides a method to check if the computation is completed, waits for its completion, and retrieves the result from the computation. So whatever task is there, it will check if this is completed and wait for completion, and it basically gets the data if it is basically callable. We'll see. The result can only retrieved when computation has been completed. There is one thing about this feature is basically we have get operation is there. And that is basically blocking operation. So till something is written from the particular thread, a system will be blocked. So it is a part of Java concurrent package for executing the concurrent task in Java. So what is callable, right? So callable versus runnable. So runnable is nothing but submitting submitting some asynchronous non-returnable run job. So if you see the runnable interface, right, it has a only single method called a run method, which doesn't have any return type. Whereas a callable is there. For example, let's see. For example, let's create a simple main class. For example, here. Let's say future demo. For now, let's do what exactly present inside runnable, right? So in the runnable, you have it is basically not returning any data. It's just a simple run method. It will execute. It will not return any data, right? For example, let's now see the callable. So callable actually has a method called call, which we can basically get some data. So for example, and it is not taking any parameter, whereas runnable also. So basically, you want to perform a thread in a callable object, and expecting some results from that thread from the task in future. Then you can basically submit a task in a callable way. So that is what we're basically discussing here. So callable interface is similar to runnable, as both are designed for the classes whose instance are potentially executed by the another thread. So what exactly callable differs is basically it can return a result. That's where we saw it has a return type, whereas a runnable don't have a return type. So the callable interface is generic type, which allows you to specify the type of object that is basically written by the call method. It can throw a checked exceptions, as it is basically returning something, right? So we can also get the exceptions also if it is fails. So it can throw us checked exceptions as well in callable. That's the two main differences between the callable and also runnable. So what are the use cases are there, right? Use cases are basically whenever you have a complex computation that required a separate thread, no need to be blocked by the main thread. So that perform asynchronously, you can use these features. And also when asynchronous operations, when dealing with input-output operations that may block file or input-output network operations, executing them asynchronously may improve the performance by not blocking the main thread. So the main thread will still can go unless you call this get method inside the future, right? That is exactly the blocking operation. So and also parallel data processing. So in application that process large data sets or perform operations like image processing using callable and features to parallelize tasks can significantly speed up the processing time. So the main thread is not depending on that. You can submit as many tasks and future will basically hold the data. Like let's do some coding. You'll understand even more better. Now let's create a fixed thread pool executor. We'll discuss what executor service in the next video only. So executors dot new fixed thread pool. Or if you want to perform a sequential operation, you can also perform a single thread pool executor also, like doesn't it will basically always create a single thread. Now let's create a callable task and submit and wait for it and assign to the future. It will basically get the data. So now let's create a callable task. String callable equals to anonymous task. Cool. Yeah, anonymous task, and here you can perform all sort of operations. For example, here let's assume it's waiting for some complex operation, maybe and ultimately it is basically returning the data, like what exactly returning string value, right? Return, let's say, hello world. And for simulation purpose, let's wait for a sometime thread dot sleep of 1 second maybe. Yeah, and it is fine. Now you can submit a task to the executor service dot submit a task. You can basically submit callable, and you can basically hold that callable in the future. So if you see, this is also from concurrent package, from Java concurrent package. It will basically hold the future. What basically expecting return type is basically string. So it has the complete data. Now basically you can perform series of operations. Your main thread won't be blocked whenever you perform future dot get operation, right? So here actually it's basically will blocked. It can be either executing this task, it might lead to execute an exception. While doing some task here, it might have thread dot interrupted, it will catch to the interrupted exception. So but this will basically get the data, like you can simply perform data, you can simply print the data. So once you're done, maybe final you have also executors service dot, you can basically shut down. Let's run the program. Okay, wait. Let's run. So here we see we got the data, right? So this is how basically we can capture the submission data, like in the future, and this get method will basically wait till it's basically computed. It will basically returns the data. So there are like some drawbacks are there in this feature because of this blocking nature. We can see this one, how can we avoid this one with the help of completable features in a minute. But let's see, like so what is exactly this completable features, right? So completable features is basically enhancement over the traditional feature interface. So completable feature implements the feature interface along with basically completion stage. So this is the extra implementations done by this completable feature along with the existing feature one. So providing a richer, more flexible and fluent API for asynchronous programming. It allows for non-blocking asynchronous programming. This is very important. Like, so the feature allows the asynchronous programming, but it's a blocking nature. But this completable feature will allow the non-blocking asynchronous programming. including the ability to manually complete the feature also, compose multiple stages of computation. Let's see what exactly this composing the computation in multiple stages. And also because of this having the control over multiple stages, we can perform the error handling in a more expressive manner. So in a completable feature, right, we have an example, we have a method called run async. So completable features can be used in many ways, but one of the simplest method to start the task is basically asynchronously through run async. Let's see the example, you will understand even more better. Completable future example. Now let's define a completable feature. We see completable feature also from Java concurrent package. Let's have this void. I'm executing normally this now. This time I'm executing only runnable instead of callable. Future completable feature equals to completable feature. If you see, we have many things. Failed async, all of will be execute all the many completable features in a parallelly, like where we have simply thing like basically run async or supplier async is there. Many methods are there. So run async basically taking the runnable method, right? Let's use this one only, run async. Let's have a anonymous method, anonymous function. Execute thread asyncly. Once you're done, you can perform a completable feature dot get. So this will basically waits till this asynchronous job will be completed. And after this one, let's simulate this one. If you execute this one, here see executed thread in asynchronous, and here we can perform as many operations we want, perform other operations, and it basically it will get the data. This whenever you perform this get operation, right, it will basically execute this one, right. It basically waits till this data is completed, till this task is completed. For example, now let's execute. You got it right. Main this completable here this completable basically we submit a job. This run async will basically submitting a job. Once submitting a job, we can do other stuff. For example, other stuff, and we can basically wait for this job to be completed, and then we basically mark it as completed. So main other stuff and starting this one and performing some operation, and it is basically completed. This is how basically how the completable feature will be worked. So what are the advantages of completable feature, right? It's a basically non-blocking operations. It provides a non-blocking way to execute, compose and combine asynchronous computations. Methods like then accept, then apply and then compose. We'll see in a minute about then accept and then apply. Allows you to perform further actions once the original task is basically completed without blocking. Exception handling. Completable feature provides a methods like exceptionally and handle that allows for more elegant handling for exceptions in asynchronous computations. Completing the computations manually. you can complete a completable feature manually using methods like complete or complete exceptionally. Provides a flexible in how when the feature is basically concluded. So, and also this completable feature has many asynchronous method support. Whatever then apply, then accept is there. Right? For every method we have a then apply async, then accept async methods are there. These methods execute the task in a separate thread, like how we saw run async, making it easier to manage the executions of a sequential asynchronous operations without blocking the caller method. So let's see some of the examples of using the then apply and then accept. Yeah. Okay, now let's define a job completable feature dot, let's say supply async let's simulate an operation. Okay, thread dot sleep and once it is done, we just written hello. So let's assign this one, create a local variable, future job. Now let's basically future job, from this future job you can basically apply some method. You can perform then apply, you can apply some method, some computation on top of this method. You're applying some job. You can perform, for example, name. You can basically, it will come the hello, and you can basically add something, world. Your whatever job is there, you are basically applying something on top of that, and you can capture this one. Applied feature. Let's name it as applied feature. And once you apply the feature, here you can basically accept that one, like then accept. Here you can perform the print operation simply. Printing. What it is there, you're getting, for example, you're getting, let's assume you're getting a message, and that message you are basically printing. Cool. Yeah, so now you basically applied feature dot, you can perform the get operation. Yeah, so here you can just execute this one for now, as we are performing only, we are not basically returning value, right, in the applied feature. So this will, what it will do, it will basically perform the hello world, as we said, is performing the hello world. So first it's basically it went to here, it wait for some time, we're supplying an asynchronous job, and it is performing some operation and returning the hello. And once the job is done, once the job is basically completed, we are modifying some operation. This also will take the basically function to apply on top of that. Once we get the function, we are basically performing an accept, which is also basically consumer, right? So we are basically printing here in the accept one. So we basically performing a supply async, then accept, then apply, and then accept. So these are, likewise we have many multiple things are there in completable feature. This is a more advanced version and better version compared to the features. So summary, basically with completable features, developers have greater control over asynchronous tasks, including error handling at multiple stages, chaining multiple steps of computations, as I said, and combining results from independent asynchronous tasks. So it's a fluent API supports for declarative systems of programming that can make more code more readable and maintainable. So this is the basic differences between the features and completable features. How can we submit a asynchronous jobs to process in different threads, and our normal threads will work parallelly. Like instead of creating a threads traditional and work on, we can apply these features which will hold the data which comes in future, like so that return types can be hold here, like. So this is the basic example of both. In the next video, we'll basically discuss about the most important topic called executive service, and also very in detail about like different kind of executive services, like fixed one, cache one, single thread executor, all those things. We'll soon meet in the next video. If you like the video, please like and subscribe and share to your friends. For now, bye bye.